All right, good morning. Sitting here working on the back of the first day's notes. So you already did page 1 notes for Unit 5, Day 1. Now I'm working on, just kidding, 30. Unit 5, page 2 of the note table. So looking at the information in the graph, it's going to ask you to fill in some stuff, and we're actually going to work with the same parent graph. So we're essentially doing the same thing we did with the initial unit we started with, where we're moving, shifting stuff right, left, up and down, flipping, reflections, that sort of stuff. Alright, so stuff to remind you, if this is a number bigger than 1, this is a growth. So as you go to the right, the curve should be increasing very quickly. Alright, so anything to a 0 power is 1. 3 to the first is 3. And here's the thing, when you do these, when you deal with the negative exponents, if you have the first power here, the negative power, or this, will be the reciprocal of that. So it's going to be 3 to the negative 1 is 1 over 3. So if I did out here, if I did to the second power, so if I did 3 to the second, that'd be 9. 3 to the negative 2 would be 1 over 9. Okay, they're reciprocals of each other. Excuse me. All right, so this growth curve, 0, 1, 1, 3. If you did 2, you could do it up at 9. 1/3, 1/9. So it's increasing as you go to the right. All right, so same kind of stuff we were doing before. So when you see something like this, it's like the parentheses, so when the number is adding, subtracting in the exponent, this is the right or left movement. Okay, so when we did the functions before, something to the x power, if I had like x minus 2 squared, this would have been, we move left, the graph left 2. So the paragraph of x squared, we would move everything left 2. So something like this one is x plus 1. We just kidding, I'm sorry, back that up. Like I said, it's the opposite of what it is. So if it's a minus 2, we actually go to the right 2. So when we do this x plus 1, since it's a plus 1, we actually go left 1. So I start with 3 to the x. So I have that initial graph. That's the parent graph. So it's going to look exactly like that. So it's 0, 1, 3. If you did 2, 9, like that. But every single point, this is a translation, it's going 1 to the left, so 1 left. Take this 1 line over. Okay, same exact graph, but everything goes pushed over 1 to the left. Now, that was when it was in the exponent. However, if the number is after the function here, so the parent graph, we're still doing 3 to the x, but now I'm doing minus 1 later, so this is a downward movement of 1. So I still start off with my initial points. So I'm using these same points that are in the table here. So those are my starting points every time. And I just take every single one of those and count down 1. So when I'm moving these things, up, down, right, or left, the asymptote, which we started talking about last time, the asymptote is actually going to move with you. Excuse me. So in this graph, or in my initial graph, my asymptote, even though my arrow is going through, my asymptote is right here on the x-axis, or the y equals 0 line. So when I shifted it down 1, my asymptote line also goes down 1. So the asymptote is now at y equals -1. So it's like we took our asymptote, we also did the translation of that down 1 also. Alright, so we're still working with 3 to the x. So when I'm asking you to graph these, the initial points you're starting with stay the same as the growth curve. Now the negative in front, this means it's going to be a reflection or flip over the x-axis. So the y values are changing. So it's a negative, so this goes upside down. This goes upside down. This goes upside down. So if the negative is in front, just like the function, just like we did before, if the negative is in front of the function, it flips up, you know, from being up to being down. The asymptote is still here. The asymptote is actually the line it flipped over, so it's the y equals 0 line. And this last one, again, we have our parent graph of 3 to the x. So this time, sorry, there's my point for 3 to the x. This time the negative is though with the exponent. This means it's a flip over the y-axis. So it's going the side-to-side movement. So flip over y-axis, which is here. This one goes that way. So if it's a growth and we flip it over the y-axis, it actually looks like it's going to be a decay, but that's just because of the reflection. The asymptote still stays here, y equals 0. Alright, the next thing we're going to do is talk about natural log. Base e, so base e to the first power is like 2.717. Oh, it just came 2.718. Oh. Like that sort of stuff. It is a way to work with some exponential functions or with some functions actually tends towards. You need to find on your calculator where the ln button is. That's the natural log. To get e, we need to press second. It's on the left hand side down by the on button. To get e, I have pressed second natural log and you'll get e, and depending on the calculator you have sorry, it will put it as e and then it'll ask you for the exponent. E does this every time, saying what exponent do you want to raise it to. So really all these down here are typing into the calculator. So you want to type second ln, I'll put e in there and type in -2. And let's do 3 hundredths, 10,000, 0.315, just a second, 0.135. So the rest of these are, just type them in and see what you get. Type it in and see what you get. The first power is 2.718. E to the second is 7.389. Okay, that's it for the notes today. We are going to do some, if you want to start working ahead, that's fine. In class tomorrow, you're going to be asked to do the page 4 of those graphs. So initially start with the parent function of 2 to the x. We're going to do those in class. Otherwise, let me know if you have questions. Thanks. Bye.